Got it. Okay.
Yeah, floor is all yours.
You want me to start?
Yeah.
Okay. Yeah. Thanks a lot, Peter, for inviting. Thank you guys for joining us. What I'm going to show today is basically like half a year ago, I gave a 10-minute version of this talk in Toulouse. So some of you may have seen some of the slides, but I'll go in a bit more details today. I'll be talking about social evolution and actually about collective action that has been extremely important for our species since its origin. And collective action ranges in scale from very small groups, like in small-scale societies engaged in collective hunting or something construction, or some building construction, to some huge projects like pyramids in Egypt or the space station. And collective action aim to produce some goods, to preserve some goods, or also collective actions are involved in different types of warfare. And collective action remains extremely important in modern times. So right now, our society faces a number of different challenges like climate, pandemics, inequality, and solving them requires not only adequate funding, development of appropriate technologies or effective policies, it also needs agreement between major stakeholders and these different parties, different agents, different individuals have to cooperate and comply. And that basically makes understanding human behavior and human beliefs extremely important for modern societies. The significance of collective actions, the obstacles that they face, and the ways kind of to achieve their success has been a topic of a philosophical inquiry since ancient Greece. And here I have pictures of different philosophers, and in their discussions, they emphasized different factors that promote collective action, like good nature of people, and different factors that prevent it. For example, for philosophers like Socrates and Plato, while it was basically there was a need, the challenge that we see was to explain people what is the best for them. And once this was done, then kind of good human nature would be sufficient to drive the collective action to success. But at the same time, we recognize different obstacles, human selfishness, resistance to change. Aristotle directly acknowledged the challenge due to different interests that people have and people's selfishness, and that was also important in the discussions of Hobbes, Adam Smith, Rousseau, and ours. And Hobbes and Adam Smith emphasized the need for a strong government that would kind of make people to overcome their selfish tendencies. Collective action was also at the center of Marx and Engels' ideas about the struggle, class struggle and revolution, and we also saw some obstacles like in internal divisions within, say, the worker class, resistance of capitalist society and things like that. As far as mathematical theory of collective action is concerned, it's emerged largely in the 50s and 60s. And the crucial step in this development was Mansur Olson's book that, among many other things, identified free riding as the main challenge to collective action. And he also put forward a particular solution: social institutions, that it means social selective rewards and selective punishment as the way to promote collective action. And a lot of research in economics was actually devoted to identifying ways to create appropriate and successful social institutions. This work was done within the framework of classical game theory, and then there have been a number of different extensions like errors in decision-making, our regarding preferences for fairness and equity, emotions, and some of these extensions actually have been applied to collective action. And then later on, evolutionary game theory emerged that removed some of the limitations of the classical game theory. And people working in this field found a number of alternative solutions to collective action problem. Kin selection, reciprocity, reputation, group selection, and partner choice. And that's greatly enriched the theory of collective action. Also in the game theoretic and economic literature, a number of additional forces and factors have been discussed, like internalized norms, and the process of internalization happening as a result of inculcation and propaganda. Herb Gintis has written a number of very important papers on this. Also, social norms and peer influence emphasized by Eleanor Olson and many other researchers in economics and in social sciences. So these factors are well known and been thoroughly discussed, but they have not been really incorporated in kind of most common, most popular, most general game theoretic models yet. However, if we look outside of game theoretic research and outside of economics research, there is a whole set of different approaches to understanding human behavior and behavioral change. This review paper published almost 10 years ago listed as many as 82 different theories that social scientists came up with. And many of these theories, they explicitly include social influence and social norms that I already mentioned in the previous slide. In fact, if I look at the theoretical developments over the last 30 years or so, a new set of mathematical approaches emerged under the rubric of social influence theory. So now, as far as human behavior and beliefs are concerned, there is a game theory and there is a social influence theory that goes back to Rashevsky model from the 40s, and then de Groot, Groenewetter, and Water model that emerged in the 70s, and cultural evolution models of the 80s. So these two fields, these two sets of theoretical research exist largely independently, although there are some attempts to kind of bring them together. And at the same time, there is an additional set of processes that are extremely important for human behavior and for what we do, for decision making. These are different psychological processes and personal norms that I already mentioned. And there is this effect of cognitive dissonance when people try to reduce the mismatch between, say, what we think and what we do. Beliefs about others are extremely important. There are some logic constraints. There are emotions that I already mentioned. And there have been some attempts to link, to incorporate these psychological processes into existing game theory and social influence models. For example, there is a branch of game theory, psychological game theory, that includes emotion. But again, the connections between these three different sets of approaches to human behavior are not as strong as I believe they need to be. So basically, kind of the ideal situation would be kind of to link all these three different sets of approaches and theories together. And that's something that I've been kind of trying to make first steps in this direction over the last few years. So kind of 3 years ago, I published a paper that introduced a particular model that attempts to bring these different things together. And there are three main components in this approach. One is what I call a norm utility approach, where actions according to particular norms become a part of a utility function. And this is a special case of what is known in economics as belief-based utility. It's been around for a long time, like Akerlof had introduced it in some models in the 80s, and then many other people done that. On top of it, that was the first component. The second component is that beliefs and preferences that are often considered as given, as static in traditional economic models can actually change. So the second component of this approach that I've been developing attempts to describe explicitly how personal attitudes and beliefs about others change as a result of social interactions. And the third component are individual differences, between individual differences, which we all know are extremely important, but traditionally they are largely disregarded in mathematical models. For example, in game theoretic models, the main differences are usually between actions or strategies. In social influence models, these are beliefs, opinions. But there are many other morphological, physiological, psychological differences between individuals that are crucial for our decision-making and belief dynamics. So they need to be included as well. So the general theoretical framework is the following. We look at a group of individuals who are engaged in some kind of collective action, can be production of a public good or its maintenance, and they care about material costs and benefits, naturally, but they also want to do what is right. We're influenced by ours, and they don't like to be disapproved by ours. We don't know actually what ours really think, but they make certain inferences about that. And they're also influenced by some external authorities, by propaganda. And the questions that we want to understand here is how individuals find the right action, what happens to their beliefs, attitudes, and behavior, and what are implications for group dynamics here. So the way I do it, here I'm kind of briefly outlining some details here. So in game theoretic models, the emphasis is usually on strategies or actions. I will use variable X or Y. In social influence models, the emphasis focus is on opinion on our beliefs. I will use variable Y for this. And in game theory models, users choose strategy to maximize their payoff. In norm utility modeling, we just add an additional component to payoffs in the utility function. For example, here, this term over there, if X is the action what you perform and Y is your belief of what is the right action to do, you pay cost. There is a negative in front of you here if your action deviates from what you believe in. So this is an effect of cognitive dissonance. Okay. And then in social influence models, there are many different approaches, but the most basic and most simple one is and the Groot was one of the first to suggest it. So here, if big Y is the average opinion in the group, when basically your Y in the next time moment after interaction moves towards the average opinion of the group. So this kind of social influence or conformity, and coefficient beta here will measure the strength of conformity. So that's how it's kind of done in this very simple way in these two different fields, in game theoretic models and in social influence models, and I will bring it all together. I want to say that the whole approach was inspired by experimental work. There has been a number of papers published in the last several years where experimental psychologists, the behavioral economists, they directly measured the variables that I will be describing in the model. So there will be 4 dynamic variables for each individual. and I will treat them as continuous. So there will be an action, X, there will be an attitude, Y. This is what people believe is the most appropriate action in a given situation. While in social psychology, people talk about attitudes or personal norms or internalized norms. And then there will be X tilde. This will be my belief what my peers will do. And Y tilde, this will be my belief what others expect me to do. And these two variables, X tilde and Y tilde, are directly related to what in social psychology we call empirical expectation or descriptive social norm for X tilde, and a normative expectation or injunctive social norm for Y tilde. Okay. And on top of that, I will add a constant effect of an external authority promoting a particular action. So we have, okay. So now, norm utility approach. So this is kind of one way to do it, what I've been using. So we have a material payoff, and then we have additional costs that individual pay as a result of different factors, forces. For example, here, this is a loss on utility due to cognitive dissonance if my action deviates from what I believe is the right thing to do, or the cost that I pay if my action deviates from what what I think my peers expect from me. And this is conformity with the action, and here is a similar term for conformity with authority. And this is an intentionally simple form with quadratic terms, and if we look for the best response here, naturally we get a linear function that predicts what I should do given my different beliefs and given what I think is the action that maximizes my payoff theta. Okay. And this is very simple, and it's also very convenient because in experiments we can just basically, I will talk about in a few minutes, we can basically estimate all these coefficients in a straightforward way. So that takes care of action X that changes dynamically. And then I generalize the Degroote model to describe the changes in personal norms, normative expectations, and empirical expectations. So here is the recurrence equations, and here like alpha, here the terms proportional to alpha describe different cognitive forces, when the same terms proportional to beta describe different types of conformity and learning. And the last set of terms with gamma describe effects of authority messaging on my beliefs. For example, here the cognitive dissonance, if my belief deviates from the action that I took, I can change my belief to reduce cognitive dissonance. And here, for example, this social projection term, I kind of think that individuals, I adjust my, if there is a mismatch between what I have and what I think our individuals believe in, I can adjust my belief to reflect my own thinking about the situation, because ours probably think somewhat similar to the way that I do. And conformity terms, it's basically capital X is the average action of my peers, and I adjust my beliefs to move it closer to what I see others are doing. And the same with conformity, with the authority. So we have this system in the sense of equations, right? Yeah, we have a system of equations, very, very simple equations for actions and equations for beliefs. And I allow for variation in all these coefficients. These coefficients measure the reaction of individuals to various factors here. So as a result, we end up with 4n dynamic equations, and equations are linear, so we can do whatever, right? And we can analyze equilibria, we can look for transit dynamics, and we can answer some of the questions that I posed initially about individual and group behavior, about individual and group beliefs, about the norms that are internalized, and so on. So I just want to say that kind of this approach I applied in that first paper to a bunch of different games, including different collective action games like coordination, public goods game, common pool resources game, tragedy of commons, but also other games like dictator, give or take, rule following. It can be applied. It was applied to continuous prisoner's dilemma game and some other games. I'm not going to talk much about this. Just will show you a few slides. So yeah, I already mentioned the general theory that was published in a couple of papers. And then we had a paper with one set of experiments published this year with a common pool experiments. And then we have another one currently in review that is a synthesis of 10 different experiments. And then there was a bunch of theoretical papers on this. But let me just say a few general results that emerged, general theoretical results that emerged from this model. So one concerns the individual actions and beliefs when external authority is absent. So in this case, average actions converge to the Nash equilibrium. Right, and that's kind of good, and that's what expected. More interesting is that individual beliefs, personal beliefs, can converge to values that justify individual actions. So in a sense, where the model predicts that people will believe that whatever they do, and what they do is maximizing their payoff, is the right thing to do. But that happens only in the absence of authority messaging. If there is a propaganda or authority messaging, then a resulting equilibrium will represent a balance between material payoffs and the values promoted by external authorities. There will be some differences between game theoretic predictions, and these differences will emerge due to social influence that will kind of be reflected in many different aspects of this model. And then the model was used to make certain predictions, for example, about the level of variation in different variables, about the ability of people to internalize detrimental norms. It predicted that under some conditions we can get backfiring effect, where people would respond to messaging in the opposite direction. And it also allowed to identify additional factors that could control the degree of tightness or looseness of different cultures. And it's social heterogeneity, societal trend, propaganda, and some other population size, and things like that. So the model, although mathematically is very simple, again, I want to emphasize that kind of after all of these steps, I end up with a linear system of equations. It is quite rich in explanatory and powerful in its explanatory power. Okay, so that was kind of, that was about the model itself. But what we've been doing after that, we've done significant effort to test this model and to validate and parameterize it using behavioral experiments. And this was done with a collaboration of 5 people listed here: Dennis, my postdoc, Andrea Gide, Julia, Anche, and Boyu. So now we have, as I think I already mentioned, about 10 different experiments. So what I'll try to do next is to summarize what we see in these experiments. First, we have 2 sets. One uses a common pool resources game, and the experiment was run in Spain and in China in different years. And we had 2 treatments, with and without messaging informing the group about the beneficial behavior. And also we use data from collective risk experiments that my co-authors, collaborators performed earlier using Spanish and such. I'll talk about the details in a bit. So the common pool resources game is a very popular game in behavioral economics, and it was viewed as a much more realistic environment than many other social dilemma games. So here, individuals make an effort in extraction of a particular resource. The group investment is X, and the production function shows diminishing return. And when individuals extract the resources, and they divide the resource that they extract in proportion to their effort. So this is a well-known and studied game. And the feature of this game is that the Nash equilibrium, the Nash equilibrium is higher than the socially optimum effort. So in this situation, game theoretic approaches predict that individuals will overexploit the available resource, and everybody will suffer. So, as already said, we ran it twice. Each experiment had 150 subjects initially. We interacted in groups of 6, and we ran it for 5 weeks, so around a day. So we had, at the beginning of each round, we had a certain endowment, 30 units, and we had to decide how much to invest in instruction. And for parameter values that we use, Nash equilibrium was at 24, but socially optimal contribution, Pareto equilibrium was at 14. And we had 2 treatments, without messaging and with messaging. And messaging was this just simple sentence shown here. The group beneficial investment is 14 units. No, nothing else. And we saw it at the beginning of each round. The way we did
question. Yeah. So you said you reshuffle these people, or do they?
Yes, we reshuffled. Yeah.
Every single time they make a decision, they get reshuffled again afterwards.
Yes.
Okay. Oh, thanks.
Yeah. Each round we encounter a random group of people. Yes.
Can I also ask a clarification question?
Yeah.
So there is no explicit punishment or withdrawal of help or reputation loss?
No.
Okay.
No punishment. No. Okay. So we before individuals make their decision on how many points they want to invest in the extraction of the resource, we elicited their beliefs. Ask about personal norms, about normative expectations, and empirical expectations. So for personal norms, we just ask how many points should a person in your group, including yourself, contribute? What do you think is the right thing to do? And the questions about what other people think you should contribute and how many people will contribute. So it was normative expectation in the first case and empirical expectation in the second case. Okay. And we had a tool to estimate their expected payoffs given their different expectations, and we informed them only about their payoffs and the contributions of group mates. That was the only information they received. Okay, so here are some results. There are 4 variables: x, y tilde, and x tilde. Action, the personal norm, normative expectation, empirical expectation. There are payoffs, and we did it in and this is for actions. On the right are standard deviations, but I will ignore the graphs on the right. I will be looking only at the average values. And there are 2 rows of graphs, one for Spanish subject and another one for Chinese subject. The 2 different lines are described 2 different treatments, with and without messaging. What is interesting here, you can see that with Spanish subjects, it doesn't seem that messaging is doing much. The actions are about the same, normative expectations are about the same, and empirical expectations are the same. There is a difference for personal norms, right? But all our things are very similar. In China, the situation is very different. In China, with Chinese subject, it looks like messaging does have a significant effect. And they're definitely for personal norms, but also for normative expectations and empirical expectations. Okay? This is another way to compare, to look at exactly the same data. Now I'm comparing Spanish subjects with Chinese subjects, red and blue. And what you can see, that Chinese subjects make much higher efforts than Spanish subjects. right? We also have higher normative expectation, empirical expectations, and normative expectations and empirical expectations. We also end up with much smaller payoffs because we overexploit the resource. Okay? And this is what happens without messaging. If we receive messaging, again, the pattern persists except for personal norms. For personal norms, the messaging results in pretty similar pattern, in pretty similar the dynamics of personal norms for Chinese and for Spanish subject. So that was about the observed patterns. But now we estimate the parameters of the model, right? And there is a whole set of different parameters, like variance coefficient B, big, right? We measure relative weights of different factors in the utility function, in this decision making. B0 is the weight of material payoffs, B1 is the cognitive dissonance, B2 disapproval by peers, and B3 is conformity with peer actions. And then there are alpha, betas, and gammas that measure the weights of different coefficients in the dynamics of beliefs. Alphas measure psychological factors, beta measure conformity with peers, and gamma measure conformity with propaganda, with messaging. Okay? And red and blue are Chinese and Spanish subject. So there are some commonalities here. For example, you see with the highest weight have where the highest values are for coefficients B1 here, and they measure the weight of personal norms. B0 material forces have the smallest weight in decision making. Okay, and you can see that B3 conformity with peer actions has the second largest effect for both Chinese and Spanish subject. And it's the same both with messaging, without messaging here, and with messaging. Also, and that's kind of interesting, is that psychological factors, cognitive factors like dissonance, social projection, and logic constraint, they play very important role without messaging. For example, here, psychological factors and conformity play very similar role. So low conformity, of course, is higher. In the case of messaging, we see that effect of messaging overweights everything else as far as personal norms are concerned, but also important as far as normative expectation are concerned for Spanish subjects, but not for Chinese subjects. Okay.
Can I ask a clarification question?
Yeah.
So what information did the participants receive? Were they receiving the average of their group, or can you tell us more about this?
The only information they received was their own payoff and the actions of their group mates.
Oh, just of their group mates. Okay, thank you.
Yeah, just the group mates. Yeah, but we reshuffled, so kind of the hope was that we will react on kind of average dynamics. So there are some commonalities here, right? But also there are some differences. You can notice that, for example, Chinese subjects have much significantly, in many cases, significantly higher effect of conformity. Like these red bars, you see where higher when blue bars. So betas measure conformity. There are differences in the effects of propaganda or messaging between Chinese and Spanish subjects. For example, Spanish subjects base their expectation of their peer beliefs on the basis of messaging, while for Chinese subjects, we just see what their peers do. There is interesting difference in this coefficient alpha 2 that measure social projection. So Spanish subjects, they seem to think that ours are somewhat similar to them, while Chinese subjects, it looks like they don't think that this is the case. Coefficient alpha 2 is significantly smaller here. So let's kind of attempt to summarize these observations, and that's basically the things that I said. Material factors, the weight of material factors actually is smaller in Chinese subjects. And this is very interesting because they make high effort, right? And it kind of contradicts to the observation that B0 is smaller for them. And actually, the reason that they make high efforts is not because they are more materialistic, but it's basically due to conformity, to higher conformity. Yeah, and there are different differences, but I think I already mentioned most of them. Okay. So besides doing what I just described, we did a lot of additional analysis. We did clustering of different coefficients for utility function, for belief dynamics, and identified some clusters there. And we also did additional tests with exactly the same set of subjects. We ran standard social value and orientation tests that allow to separate like individualist types from prosocial types using, I believe it's ultimatum game, that's my recollection. And then also ran rule following tests that allowed us to split our subjects into rule followers and rule breakers. We also identified stubborn individuals who would refuse to change their beliefs or opinions and their actions, and also conditional compliers who can comply with with messaging only if ours comply. So there is a lot of interesting variation there. But what I want to talk about is a very striking effect of backfiring, where is culturally linked. So here I'm looking at two groups of individuals, prosocial types and individualist types that are identified in a separate set of experiments. And the thin lines here is their behavior with no messaging. For example, you can see that in Spain, with no messaging, individualist and prosocial types, they behave in a very similar way. Okay? But once messaging is introduced, what happens is rather interesting. Now, prosocial types, blue types, reduce their effort. They follow the messaging, but individualist types increase their effort. This is a backfiring effect. Okay. And as a result, the average will stay about the same. Remember, I mentioned that if we look at the average actions, it doesn't look like messaging makes any difference, has any effect. But that's mistaken because half or approximately half of the group do reduce their efforts, but another half of the group will actually increase it. And what also interesting, that is only observed only in Spanish subjects. In Chinese subjects, prosocial types reduce the messaging somewhat, but individualist types also reduces somewhat. So this backfiring is observed only in Spanish, but not Chinese subjects. Also, we can look at what happens as we can try to explain this difference by looking at the coefficients. And what this analysis reveals, that there are at least two different pathways to be prosocial in these experiments. In Spanish subjects, prosocial individuals pay more attention to their personal norms, while in Chinese subjects, prosocial individuals are those who have higher conformity. So that was for the case of these tests that divided subjects into prosocial and individualist types. But we saw a very similar pattern when we divided them into rule followers and rule breakers, again using a separate set of experiments. And again, what we see is that without messaging, rule followers and rule breakers, they have similar dynamics as far as their actions are concerned. Rule breakers actually make smaller effort here. But once messaging is introduced, thick lines, in Spanish subjects, rule followers reduce their effort while rule breakers increase it. In Chinese subjects, rule followers reduce their effort and rule breakers are not affected. And again, here we can see that, well, there are differences in the coefficients. And again, rule followers seem to have higher weight of personal norms in Spanish languages. Now what kind of we have the model and we have estimates of coefficients, we can see how good the model is in actually describing the dynamics that we observe in experiments. So what we did here, we took initial conditions, we took our estimates of different parameters, what we got from the model, and then we iterated our model for 35 time steps. And what you can see here, that the match is quite good, given the huge number of different parameters, large individuals, large number of individuals, and variation between them. So the overall fit is good, but there is also some mismatch. For example, you can see here, the blue lines are observed data, and red and kind of this yellowish curves away are different types of predictions. But there is also a mismatch. So what we did, we looked into the causes of mismatch in more details, and we found what is basically coming from two types of individuals. Some are stubborn individuals who refuse to change their beliefs and their actions, so we're not really fit well that's why it goes like that. But then there are also conditional compliers whose response is not described well by our linear model. So basically, we show some non-linear there are some non-linear patterns in their decision making. So we produce this mismatch that exists.
Sergey,
Okay. Yeah.
I'm sorry. This is Ingela. Hi. I must have missed something. So, what are the predicted trajectories based on here again?
We take initial conditions, right?
Yeah.
What the individuals did, and when we take our estimates, and then we just iterate it forward.
Okay. So you use the data to do the estimates, and then you compare the predictions.
Yes, exactly.
Okay.
Yeah.
Okay.
And what do you use as initial conditions, especially for beliefs? Do you ask them before?
Remember, we ask their beliefs before we make the first action, before we take the first action.
Okay, great, thanks.
Okay, so that's kind of about the common pool resources experiments. And then my collaborators, we actually ran early collective risk dilemma games. So when we got access to the data we had. And the general setup was pretty similar. There were 100 subjects initially, random groups of size 6, 28 rounds for 4 weeks. Each individual had a particular budget of 100 units, and we were to contribute it to a common pool to prevent a risk. So if I accumulated 300 units, a risk was definitely prevented. But if the amount that we collected was less than 300, then they could lose everything. And there were like 2 risk treatments with probability 60% or 90%, they could risk everything. So this is a game in which there are 2 Nash equilibria. One is where there is 0 contributions, and now one is a fair contribution where each of the 6 individuals contribute 50 units. So we have 300, and in this case, people don't lose the risk. That doesn't really matter. Okay, and then we ran it twice, and we changed the risk pattern. So it was a kind of more complex scheme, but nevertheless, we decided to see if we can apply the model to this data as well. I'm not going to go into these details. I'm just going to compare the parameters that we estimated in the common pool resources game and collective risk game. And again, there are some commonalities. The weight of personal norms is the highest. The weight of material factors is the smallest, as far as decision-making is concerned. Conformity, normative expectations, conformity with peers is the second highest. Again, there are different effects of both cognitive and factors like cognitive dissonance, social projection, and logic constraints are often as important as conformity. Okay? But at the same time, there are some differences between two games. But these differences they make they make sense. For example, in the case of collective risk game, it's pretty much clear to individuals what to do, right? Because kind of making this fair share contribution is kind of it's very easy to compute what is the right thing to do. So from this cognitive perspective, you see the weight of social projection is much higher in common pool resources, because basically we expect others to do the same thing as I do. And also the personal norm weight is higher, because again, it's clear what is the right thing to do. So there are, as I said already, some commonalities between the experiments, and some general, and as far as the differences are concerned, they make sense. So that's basically what you expected given the setup of the experiments. Okay, so now I'll just go over some general conclusions. So I started my talk about talking about the need to unify kind of these different perspectives on human behavior and human beliefs. And this is what the model did, and that's what these experiments did. And the cool thing about this approach is that it's model-based. I'm talking now about experimental approach, but it's model-based. It's not just we estimate significance of particular factors in the experiments. We have a dynamic model, and it allows us to extract much more information. Moreover, we measure all these forces on exactly the same scale. So we're not comparing apples with oranges. The weights that we get with are relative weights of different parameters, different forces, which simplifies greatly interpretation. And we validated this modeling framework in several experiments with different types of social interactions in different cultural groups, and the results are consistent, make sense, and supported by intuition. So as far as decision making is concerned, our results show that personal norms are very important. All parameters are statistically different from zero, but the most important factor in these results was personal norms. Material factors had the smallest weight, and the effects of social influence by peers were intermediate. Beliefs were important in decision making, definitely. And beliefs and these cognitive forces resulted in significant loss of material payoffs for individuals. Belief dynamics are also important, and pretty much all these parameters, again, are significantly different from zero. That means we need to count not only conformity with peers, as is usually done in social influence models, but also we need to include the psychological factors of cognitive dissonance, social projection, logic constraints, and things like that. Authority messaging is important, but what is most interesting is that authority messaging is important mostly for personal norms. It's significantly less, and authority messaging is measured by coefficient gamma. It's significantly less important for normative expectations and for empirical expectations. And also what is interesting, there are these cultural differences, again, like Spanish subjects given in blue, they think that authority will affect peers in the same way as it affects themselves. For Chinese subjects, these weights are significantly small. There is a lot of between individual differences. It's basically and these differences can concern decision making. It concerns belief updates. It concerns how people react to messaging. Our results also show that looking at the average dynamics can be very misleading. There is a lot of variation that can be hidden. Also, the results of our experiments allow to identify different types of prosociality here, and these types differ and there are cultural differences in these types. Also, there are important types of individuals like stubborn and this conditional compliance that we found here. Yeah, we also checked for differences by gender, but were not where gender did not heavily influence the results that we saw. Messaging was very important, but it was mostly important for personal norms. And once personal norms are changed by messaging, it kind of has secondary effect on individual actions. Messaging can trigger expression of pro-social and rule-following tendencies. I showed that our experiments showed that in some cases there is no difference between pro-social and individualist types without messaging, but messaging triggers. And also messaging can cause backfire. And of course, we identified a lot of cultural differences between Chinese subjects and between Spanish subjects. And these differences mostly can concern effects of conformity. And this conformity actually leads, high conformity in Chinese subjects leads to higher efforts in the common pool resources games. And also there are differences in how authority influences beliefs between Chinese and Spanish subjects that I already discussed. And cultural background interacts with messaging in different ways. For example, as already was mentioning, the messaging causes backfiring in Spanish subjects, in individualist or rule breaker types in Spanish subjects, but not in Chinese subjects. Okay, so that's kind of the stuff that we've been doing. And there are many ways to generalize these approaches, both from theoretical point of view and also experimental work. Different games can be considered. Particularly important would be to look at games that stimulate emergence of stronger social norms. Different types of messaging, perhaps those that exploit social identity. Repeating the experiment in different cultures and contrasting the results would be extremely important. And actually, it's something that we are working on. We're now building a consortium, so we're going to run these experiments in 10 different countries, hopefully next year. And then finding applications to real life would be very good. So how can we use that to promote collective action? So basically, to do that, we need to understand the weight of different factors that affect it, and it is personal norms, descriptive norms, injunctive norms, authority messaging. So and the fact that different individuals react differently to these forces. So all this needs to be accounted for when different policies are developed. So the results kind of suggest that messaging should target particular clusters of individuals that can hopefully be identified or even be highly personalized to push individuals to do one thing or another. Okay, thank you.